Hey, coming to you from my ceiling. Get it? Ceiling because I'm upside down? Really, this is the second time I've taken this video. And the first time, everything was backwards. And I said, screw it, I'm just going to be upside down. So clearly I'm not in class today. Actually, today is Sunday. And I was at school, but you weren't. So I think we're even. But today, Thursday, you're going to learn how to balance chemical equations. I'm probably somewhere in North Dakota or Montana. Hopefully, if I don't die in an avalanche, I'll be back on Tuesday. So with that in mind, we got to review what are chemical equations. So we're going to go these guys. Come on, focus. I was talking to the camera, not you guys, but you as well. So remember that chemical equations here is our shorthand lazy way to describe what's happening. But as you can see right here, we've got 2 chlorines there. We've only got 1. Just as a review, everything you start off with are reactants. Then over here are products. So the number of chlorines there's 2. We got to have 2 over here. So just to help illustrate this a little bit better, I went ahead and I cleaned out all the change in my car. And there was some other random stuff like a guitar pick and a washer. But those don't really get to participate in our activity today. So let's say we're starting with a quarter. Okay, if we want to go ahead and exchange this quarter into some different denominations here, we could go ahead and we could have 5 pennies, we could have a dime, and we could have 2 nickels. Okay, so if this right here is my reactant, my products have still got to have that same value. So 10, 15, 20, 21, 22, 23, 24, 25, boom, we're good, we're balanced. We've got the same on one side, same on the other side. So that's the whole premise here. Remember, we cannot create or destroy matter. It's conserved, aka the law of conservation of mass. So there's a lot of different laws of conservation, but they're all basically saying what you start with, it's got to be equal to what you end with. So in a chemical reaction, we're breaking the chemical bonds here. We're going ahead and reforming it. So we're making different stuff over here, but we've still got to have our same number of atoms, or in case of our analogy here, we've got 25 cents here, we've got to have 25 cents here. So now, this entire sheet, I'm not going to tell you that it needs to be done by Tuesday, because I'm going to be straight with you. This sucks. You're not going to enjoy it. But I'm going to give you some helpful hints. We could think of these as pro-level tips that'll be beneficial to you going forth. Just one moment. I'm going to put another light on. I could pause, but I'm not going to, because you only have 24-minute classes today anyways, and you probably screwed around for 2 minutes before the bell started. So you have access to YouTube, and you could always ×2 the speed. Let's see. No, the shadow's worse there. Let's see. Oops, wrong way. I think we're just going to go with it. All right. I can move this. Yeah. Yeah. No. Okay. So there are a few helpful hints when we're doing this. Remember when I said a couple weeks ago that if you don't know how to tell me what's in each one of these little jobios, reading chemical formulas, you'd basically be hosed? Yeah, this is where that's coming back. So first thing that I like to do is go ahead and split my products and my reactants. So I'm going to list what I've got on both sides. So I've got carbon, I've got hydrogen. Oh, stupid pencil lead. It's because I stole this pencil from my daughter. Carbon, hydrogen, and oxygen. Now I've got carbon, hydrogen, and oxygen over here. So obviously what you've got on one side of the equation you're going to have on the other side. So I've got 3 carbons. I've got 8 hydrogens. Leah, Hannah needs you. Gosh dang needy daughter. And then you have 2 oxygens. Oh, I only have 1 needy daughter, not 2, just in case you're curious. Carbons, we've got 1 there. Hydrogens, we've got 2 there. Oxygens, we've got 2 plus 1, so 3. So, key thing to keep in mind here, where there's these little boxes, that's where you can add coefficients. We don't balance chemical formulas by adding subscripts like this, because this is carbon dioxide, okay, CO2. That's the stuff that we exhale as a waste product after cellular respiration. If we get rid of that 2 and it's just 1, that's carbon monoxide. That's the stuff that kills you if your ice house heater doesn't work properly. So they're different. So when we're balancing equations, I always like to go carbon first, then hydrogen, and then oxygen. It just seems like if you do carbon first, then hydrogen and oxygen, it balances out better. And what do you know? We've got carbon, hydrogen, and oxygen all right here. So we've got 3 carbons here. We only have 1 there. So in order to make that 3 carbon, guess what? I got to put a 3 there. Boom. Did it. So now, obviously, that's going to screw up my oxygens. That's fine. I'll get to that later. But I'm not concerned about my oxygens now. I'm going to go ahead and do my hydrogens. So if I've got 8 over there, I've got 2 over there. What times 2 is 8? Yep, I hope you're saying 4 internally. All right. So I've got my carbons balanced. I've got 3, I've got 3. I've got my hydrogens balanced. I've got 8, I've got 8. So now I'm going to go ahead and recount out my oxygens. So I've got 3 times 2 is 6 right there. See, the 3, the coefficient, distribute that over. And then I've got 4. So 6 times 4 is 10. So now when I go ahead and go over here, well, what times 2 is 10? That would be a 5. So as you can see now, we've got 3 and 3, 8 and 8, 10 and 10. We are done. Okay, that's the first one. So that's all there is. If you want to go ahead and start working on this on your own, that's fine. You're going to struggle. So let's do a couple more. All right, I'm going to go down to number 4. It looks nice and easy, but it's one that you might bash your head against a wall for a while on. Okay, so we've got H2O2, that's hydrogen peroxide. Feed that to your dog if you need to barf something up. So we've got hydrogen and oxygen. Oh, also, there is one problem on this worksheet that is balanced. That means you don't need to do anything to it, just as a helpful hint there. All right, so I'm going to count up. So I've got 2, and I've got 2, and I've got 2, and I've got 1, 2, 3. All right, so here's the issue. Odd numbers suck here, okay? We talked about doing carbons and hydrogens and oxygens. Great, okay? So my hydrogens are already balanced, 2 and 2. The issue is my oxygens are imbalanced. Here's my problem. 3 and 2, those two things are never going to jive. So here's what I'm going to do. Let's try to turn this 3 into a, let's say, a even number. So yeah, you're probably like, well, 3 times 2 is 6. We could make it 6. Yeah, you could, but we're not going to. Maybe that's why I chose this one. So what I want to do is I want to turn this 1 oxygen into 2 oxygens. So I'm going to go ahead and just put a 2 here. Yes, I know it screws up my H's. Deal with it. You're going to have to change your H's anyways, or else it's never going to be balanced. So now I've got 4 hydrogen. I've got 2 oxygen there. I've got 2 oxygen there. Nice. Okay, so I've got 4 and 4. Oh, well, I've got 2 and 2 here. So what times 2 is 4? Oh, I think it'd be 2. Oh. 4H, 4O is boom. I'm done. See, this isn't so bad. Oh, this one down here looks like it could be tricky. I see some big numbers. Let's do number 5 now. And let's see, my timer is at 9 minutes and 14 seconds. I've almost taken half of your class time. Outstanding. Unless you guys got smart and had the sub put on ×2, or you're watching it at home. All right. Or you're watching it early because you don't have a life, so you're bumping up the YouTube subscriptions. All right, so we've got carbon, we've got hydrogen, we've got oxygen. I will say on some of these, you're going to struggle because you're not going to add these 2 oxygens. You're going to be like, you just have 2. Nada donna, lemonada. You also got that one. That'd be a big old 3. All right, so here we've got 1 carbon, we've got 2 hydrogen, we've got 3 oxygen. So we can go ahead and look over here on the other side. Count, we've got 7, we've got 8, we've got 2. So let's go ahead and start with our carbons. We've got 7 on this side. Let's go ahead and throw 7 there, see what we get. Okay, so now if we go ahead and look at our hydrogens, like I said, I'm not going to care about counting up any of my oxygens yet. Yes, it's going to change them, but I know I've got to do something to my hydrogens first, which is going to change the oxygen anyway, so it'd just be a waste of time. So let's just move on. So H, I've got 8 there. What times 2 is 8? That would be a 4. So I'm going to go ahead and put an 8 there. Now I'm going to count up my oxygens. So I've got 4 times 1, because remember this subscript only goes to the H, so I've got 4 oxygens there. Then I've got 14, because 7 times 2 is 14. 14 plus 4 is 18. Whew. What times 2 is 18? Wait for it. That would be a 9. Also, all these blanks, just leave them blank, because putting a 1 there would be redundant. You don't got to do that. Alright, so I think that I will do one more number here. So we're going to go ahead and move the camera. Alright, number 8. That's where we're going. Alright, now we got more elements here. So I'm going to follow along with my C and my H and my O example there. Okay, so don't get confused by that. I just put that there to show you we do our carbons first. If there's no carbons, we do hydrogen, then we do oxygen, and then you just figure it out. So I'm going to erase that because you're going to be like, why did you put that there? And I'm going to look at all your papers and I'm like, why did you put that there? Well, because I put it there. So I'm going to go ahead and list my hydrogen. List my oxygen. I've got iron, Fe. I've got potassium, which is K, and I got bromine, or bromine. Also, you might find it easier to do all this work on a separate sheet of paper because I am a mean person and didn't give you many margins. Actually, that's a Mr. Gary issue because he says I make too many copies, so just get upset at Aubrey. That seems like it'd be fair. Alright, so H's and O's, we got 3 of each. We got 3 there, we got 3 there, we've got 1 K, we've got 1 Br, we've got 1 Fe. Great. Moving it over to the other side, we've got 1 H, we've got 1 O, we've got 1 Fe, we've got 1 K, we've got 3 Brs. So, I'm going to go ahead and balance my H's first. I'm going to put 3 there. Great. That balances my O's, it balances my H's. So, on some of the other problems, I said don't worry about counting them. I'm going to count them now because I've got to find out what I've got to do over here and all that other jazz. So, I've got a 3, I've got a 3, my K is now at a 3. So now I can see my H's are good, my O's are good, my Fe's are good. Okay, my K's are not good. No, that's a 3, that's a 1. So, I've got to make this 3 become a 3 over there, so I'm just going to go 3 there, boom. So now I've got 3 potassium, those 3 go over to bromine. So now when I look, boom, boom, 3, 3, 1, 1, 3, 3, and I am golden, wonderful, perfect. So I would say by Tuesday, you guys should have at least half of this done. There's 20 problems, and I just did 4 of them, so I already didn't wait for it, 20% of it. If I said you need to get half of it done, that's only 30% more. If you're still watching, you should be working. So you can watch this as many times as you would like. And just think about it, you're doing this not being upside down like me on the ceiling, so it should be much easier for you all. So with that in mind, have a great day. Half of it done for Tuesday. Adios.